Hello, this is Xunxue from Columbia University Department of Electrical Engineering, and in this video I will introduce our final project for class Big Data Analytics, and our topic is Yelp Personalized Recommendation System. My two teammates are Zhang Yuliu and Linyu Zhang. In this project, our goal is to give the users not only the basic recommendation results, but also provide users the result adjusting based on their specific input. So in this video, I will demonstrate the basic algorithms we used, and then I'll show a tiny web app we built for the demonstration of the basic process of this project. So let's start from the dataset. The dataset we use is from the Yelp Dataset Challenge, which is an online source dataset we can download from the internet. The dataset is about 2 gigabytes large. The first step we need to do is some data preprocessing. We need to get the data we need for this project. The main data we need is contained in 3 files. The first one is the CSV files, which contains the user ID, business ID, and the ratings from a user to a corresponding business. And this files is for the collaborative filtering part. And the next 2 file is dictionary files from the to match from business ID to the reviews and the business ID to the business names. And so this 2 dictionary files is for the topic modeling part. So let's introduce the collaborative filtering. Collaborative filtering is served as the basic recommendation algorithms for our recommendation system. What collaborative filtering means is that we're collecting preference or test information from many users and then make predictions about interest of the specific users based on these results. So our implementation is based on the library Spark ML Lab, which in this library the implementation is based on the algorithms alternating least squared, which is ALS. In this algorithms, what we need to do is to optimize this formula. The first step in this algorithms is to initialize U and V. U refers to the user's features and V refers to items features. So next we will fix U to solve V and then fix V to solve U and repeat this process again and again, and at last we will get the optimization of both U and V. So in this process, we will learn the features of both users and items, and then we can perform the similarity calculations to get the recommendation results. So let's see our experiment. In our experiment, we get root mean square error of 1.36 with just 25 iterations. So, however, just collaborative filtering cannot be a personalized recommendation system. The main problem of this algorithm is that this algorithm treats users' characteristic as a consistent feature. However, in reality, that is not the case because users' mood is changing every day. For example, one user might want to eat some Chinese food today, but he might want to eat some Mexican food in another day. So consistent recommendation results may not be good enough for this dynamic requirements. So our solution is let the user participate in this recommendation system and let them be a part of it. So in order to achieve this goal, we built an interactive recommendation system on top of that static one. What that means is that at first we calculate the basic results by the collaborative filtering, and then we do another filter based on users specific input, so we can adjust the result and give the users a second input to meet their specific requirements. So let's run our web app and see what's happened. We use Flask to implement this tiny web app, so we can run to use Spark Submit to run this app, since it's all compatible. So let's go to this website. So in this website, we'll just click the submit button to launch the model, which means that we'll load the model we pre-trained for our collaborative filtering system. So after we load the model, we will get a very primitive interface to let the user input the user ID and the keywords. Let's try we just input the user ID and see what's happening. Click submit, and then in the backend, it will just calculate the results, the top 10 results for the collaborative filtering. So we can see the front end for the name of the for the name of the restaurant. So what if the same user have some specific requirement? For example, user 15 wants to eat Chinese food today, so user 15 will input his user ID and then input Chinese and then click submit. So in this process, we will run the topic modeling for the result of collaborative filtering. So let's see the main process of our personalized recommendation system. In our personalized recommendation system, we first generate 100 results by collaborative filtering, and then we conduct the topic modeling for the review of this 100 restaurants. And then we extract the keywords generated by the topic modeling and match the user's input with the keywords for the original 100 results. So in this process, we'll match the user's requirements with the restaurant's features. So at last, we will calculate the similarity, the word similarity, and then output the top 10 result for the users, which will match the user's specific requirements. So let's briefly talk about topic modeling. The key idea of topic modeling is to find a low-dimensional description of high-dimensional text. In this context, the low-dimensional description refers to the keywords, and the high-dimensional text refers to the reviews. So after we perform the topic modeling, we will get the keywords representations of the restaurant's features based on the review of that restaurant. So before we perform the topic modeling, we should do some data preprocessing. The three main steps of data preprocessing is tokenizations, setting some stop words, and constructing the documental matrix. The algorithms we use for topic modeling is latent semantic indexing. The key of LSI is we use SVD to calculate the similarity matrix. SVD also refers to singular value decomposition, which is an engine decomposition approach widely used in machine learning. So at last, we will compute the cosines between the query vectors and prepare for the output. We use JSON to implement topic modeling. And then we will calculate the word similarity between the user's input and the keywords for the restaurant and output the top 10 results for the users as our recommendations for personalized results. So that is our project. Thank you for listening.